Geometry, we are starting a new unit today. It is Unit 7, which is all about coordinate geometry. I'm really wishing that you had your printouts or at least graph paper. So this is going to be interesting. I am begging you all just to do your best and follow along with me, okay? You're welcome to take notes, grab some paper. Okay, first of all, how far is point A from point B? How would we figure that out? Is it something where I'd be like, I don't know, let me grab a ruler and just measure that distance? Okay, no, that doesn't work so well, but I do know that distance and that distance. This is 3 units. That's 4 units, which means we know the Pythagorean theorem. This could be 9 plus 16 is 25, which means C is 5 units, right? So that's the distance from A to B. Now, what transformations? We talked about transformations a long time ago. What transformations will take point A to point B? What do you guys think? Okay, how about a translation? We could say a translation along vector AB, right? We go from A to B. Or we could say a translation from -3, 5 to, let's see, that's 1, 2. 1, 2. That would also work. Okay, here it's going to be important for you to watch the videos a little slower than you're used to and take some notes if you need to. And please know our lessons are always on the internet, and that is saved for you on Google Classroom. I saved the internet. I saved the web address, which is im.kendallhunt.com. Okay? All right, let's move on. So here we're going to practice transforming a figure on the coordinate plane. When you were younger, we would do this with tracing paper, but we're not going to do that with tracing paper today because, well, we're distance learning, right? We could probably just figure out how things rotate and where things need to go. So let's just get to it. Rotate figure H clockwise. Remember, that's how it goes with the clock. Using center 2, 0. So let me use the yellow highlighter. That's our center. Oh gosh, it didn't work. That was the eraser, sorry. Center 2, 0, right there. 90 degrees. So we're just going to turn it 90 degrees. So I'm going to stick with yellow here for this first one. Means I'm going to turn this 90 degrees that way. So that would be that length, and then that length, and that was 3. Oh, but that went 4. So I went too far. There we go. Okay, we rotated it 90 degrees. Now how about translating the image? So first we did yellow, and then translate the image by the directed line segment from 2, 0 over 2 up 0 to 3, -4. So I'm going to go 3, 1, 2, 3, 4. So we're moving it from here to there. That just means that's 2, there's 2. So I just slid it. I'm going to label that result R. Okay, not too bad. Check. Now let's reflect figure H across the y-axis. So here I'm going to do that with red. Across the y-axis I'm reflecting, so and then rotate the image counterclockwise. using center 0, 0 by 90 degrees. Okay, so this one's a little bit harder. So this point here is going to rotate down to there. And then I'll just start counting. 2. This point here is going to rotate down to there. That's going to be 3. Yep. And we're going to label that L with blue. Okay. Pretty fun. Not too bad. See if there's anything else I needed to. I guess, I mean, we've done this, so do I need to talk to you about reflecting over the y-axis? So we're really just reflecting over the y-axis. Then we have clockwise is this way, counterclockwise is this way, 90 degrees is going from one quadrant to another. Yeah. You guys are just gonna have to message me if there's some words that you're unsure of that I didn't go over, because it's not fair for me to assume, but I think I've hit all of them in this slide. All right, last bit. Now we're talking about congruent by coordinates. Okay, so we're going to calculate the length of each side in triangles ABC, which we will do in blue, and triangle DEF, which we will do in green. So let's do DEF first, since I'm already there. This is 2 units, that's 3 units, and let's use our Pythagorean theorem. 2 squared plus 3 squared equals c squared. I'm going to get out my calculator. I have 4 plus 9 is 13, so I need the square root of 13 equals c. I'm going to round. 3.6 equals c. Cool. Now let's try this one. 2, 3, and then that doesn't look like a point there. Same thing. 2 squared plus 3 squared equals, let's call it d squared. Square root of 13 equals 3.6 equals d. So calculate the measure. So we've got all the sides measured. Now calculate the measure of each angle in triangles ABC and DEF. Okay, this right here, we know some of the measures of the triangles. So I'm in blue. I know that angle B is 90 degrees. Now, the measure of angle, let's say A, is going to be, if we do A, if I do opposite over adjacent, that's going to be tan of A. We learned that a long time ago, didn't we? Tan of A is 2 over 3. So if we do that, tan of -1, 2 over 3, handy dandy calculator. Remember, you need to be in degrees, so hit your mode, make sure you're in degrees, and then I'm really hitting tan -1, 2 divided by 3, close the parentheses and hit enter, and that is approximately 34 degrees. So we have 90 degrees, 34 degrees. I'm going to do 90 minus 34, which I believe is 56. Yep, 56 degrees. So that gives us the measure of angle A, the measure of angle B, and angle C. Now, with triangle DEF, I have the same side measurements, so I know my angle measurements are going to be the same. Angle E is 90. That's a bad 0. Angle D is 2 over 3. So tan of D is 2 over 3, which is the same as A. So D is going to be 34 degrees. And F is going to be 56 degrees. So the triangles are congruent. How do you know this? Well, we know because of side, 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 or side, or angle, side, angle. Okay, those are all great ways that we would know. We could say C, P, C, T, C. Congruent parts of congruent triangles are congruent. All corresponding parts are congruent, so the triangles are congruent. And then part 4. Because the triangles are congruent, there must be a sequence of rigid motion that takes one to the other. Find a sequence of rigid motions that takes triangle ABC to triangle DEF. This number 4 here is what we used for proof when we were doing congruent triangles. Okay, we knew that if there was a sequence of rigid motions, then our triangles are congruent. So let's talk about this for a second. So I got you a new graph to make it all clean. So we need to figure out how to get, goodness, are we doing ABC to DEF? Yeah. So we want to rotate counterclockwise. And if we do that, we could rotate it really anywhere. We could rotate it on point A. And there's so many different answers to this, so I'm just giving you one. Rotate along a center A, 90 degrees counterclockwise, and that would get us here. So I'm going to have A, B is going to be straight up, 1, 2, 3, and C is going to be over 2. See, coordinate geometry is actually a bit easier than when we did it before, just using our compass and protractor. So we just rotate it. Now we want to, let's change colors, translate it. And then translate, it's called a directed line segment. We used to call it a vertex. Vector. We used to call it a vector, sorry. From, let's see, over 2, up 1, to -3, 0. Okay, 2 steps. Good job. That's actually it. All right. Please go to Google Classroom for directions on your homework, okay?